Welcome all. Now I am going to explain question number 18 from the GATE 2021 paper Electrical Engineering. The question is, the power input to a 500 volts 50 Hz 6-pole 3-phase induction motor running at 975 rpm is 40 kilowatts. The total stator losses are 1 kilowatts. If the total friction and windage losses are 2.025 kilowatts, then the efficiency is in percentage. To know the detailed modeling and equivalent representation of induction motor, audience can go through the given NPTEL video link. Let us discuss some useful information to solve the problem. With the help of the equivalent diagram of induction motor, let us understand the concept. We give stator input at the stator terminals, right? So there will be a stator loss, that is magnetizing and resistance loss. So some power will be lost in the stator. So power supplied to a stator minus losses in the stator is the rotor input to the induction motor. After the rotor input, there will be some rotor losses in the rotor core. So there will be a rotor loss. Then we will get this is the gross mechanical power. After that, there will be some friction and windage losses in the rotor. Then we will get the net mechanical power output at the rotor. So the total input power to a stator is equal to stator loss plus rotor power output plus mechanical losses in the rotor. So stator input power minus stator loss can be given as the rotor power input, that is equal to the rotor loss plus rotor power output and the mechanical loss. Here the relation that describes the rotor input, rotor loss and the net mechanical power output to a induction motor is given by this expression, that is 1:S:1 minus S, where S is the slip of the induction motor and it is calculated as follows, that is Ns minus Nr divided by Nr, where Ns is the synchronous speed of the induction motor, Nr is the rotor speed of the induction motor. Using this information, let us solve the problem. Given it is V is equal to 500 volts and frequency is 50 Hz. Number of poles is equal to 6 and it is a 3-phase induction motor. Also it is given that rotor speed is equal to 975 rpm and the power input to a induction motor is equal to 40 kilowatts and the stator loss is equal to 1 kilowatts and the friction and windage loss, that is mechanical loss in the rotor, that is equal to 2.025 kilowatts. What we need to find out is efficiency of the induction motor in percentage. First, we need to find out the output power from the stator. Output power from the stator is equal to input to the stator, that is Pi minus stator losses. Input is given as 40 kilowatts minus stator loss is 1, that is equal to 39 kilowatts. This is the output from the stator or rotor input. Output from the stator or rotor input. So We know there is a relation between the rotor input, rotor losses and rotor power output is equal to 1 is to S is to 1 minus S, where S is the slip rate, we know. So slip is equal to Ns minus Nr divided by Ns. So Ns is how much? We need to calculate. Ns is, formula for the Ns is equal to 120 into F by P, that is 120 into 50 divided by number of poles are 60. So that is 1000 RPM. 1000 RPM, right? So just now we found out 1000. 1000 minus rotor speed, it is given 975 divided by 1000. That is equal to 0.025. Slip we found out, right? So after finding the slip, we can calculate the rotor output. And we know that rotor input, just now we found out, that is 40 minus 1, 39 kilowatts, right? So the rotor input is 39 is to rotor power output, we need to find out, is equal to 1 is to 1 minus S. So 39 by rotor power output is equal to 1 by 1 minus S. S is 0.025. If we solve, we will get rotor power output is equal to 38.025 kilowatts. 38.025 kilowatts. This is the rotor power output. But in the question it is given that there is a friction and windage loss. That is, mechanical loss in the rotor is 2.025 kilowatts, right? This is the loss, mechanical loss. So mechanical loss is 2.025 kilowatts. So the net mechanical power output is gross output, that is 38.025 kilowatts minus mechanical loss 2.025 kilowatts. That is equal to 36 kilowatts. This is the net mechanical power output of the rotor. So the efficiency is net mechanical power divided by stator input into 100. That is, net mechanical power is 36 divided by 40 into 100 equal to 90%. So the efficiency of the induction motor is 90%. So the efficiency of the induction motor is 90%. Thank you.